Earthquakes occur when large sections of rock in the Earth's crust suddenly break or shift, releasing energy in the form of vibrations. Most earthquakes occur at plate boundaries. The friction of a sinking plate rubbing against a continental mass causes earth tremors. When plates do not collide head-on but scrape past each other, cracks called faults appear in the crust of the Earth. Some of these faults, such as the famous San Andreas Fault in California, are visible at the surface. The movement of rock along the fault is usually met with great resistance. As the rock bends, pressure builds up slowly, and eventually the rocks snap like a giant rubber band. The greater the buildup of pressure, the stronger the jolt produced by the sudden release of energy. This sudden jolt causes vibrations, called seismic waves, to radiate outward in all directions from the source of the earthquake. In Activity 11, students learn what causes earthquakes and model the destructive potential of vibrations in the earth. They learn about a third way in which crustal plates move and model the movement of plates as they slide past each other. This activity will take about 40 minutes. The vocabulary introduced in this activity is earthquake, fault, and vibration. For this activity, from the kit, you will need, for each team of 2, 5 dominoes and 1 rubber band. In addition to the kit materials, you will need to supply a pair of scissors. Make copies of Activity Sheet 9 for each student. Students have already explored what happens when sections of the Earth's crust separate and when sections collide. In this activity, they will look at another type of interaction between crustal plates. Students are grouped in teams of 2. Each is given a copy of the activity sheet and a pair of scissors. Students are directed to cut out the plate pieces along the dotted line and reassemble them. Kathy, what do these plate pieces represent?
Well, they represent the Pacific Plate and the North American Plate.
Okay. The arrows on these plates show the direction in which they move. In reality, the North American Plate is moving more in the direction of west than south. But for the purpose of this exercise, the arrows have been drawn to move more diametrically. What is happening to these plates?
If I move them, in the direction of the arrows, they seem to slide past each other.
Okay. A fault is a crack or a break in the Earth's crust where 2 plates slide past each other. Usually a fault lies below the Earth's surface, but sometimes it appears as an actual crack in the surface of the Earth. Do you see a fault on your plate pieces?
Yes, I see the San Andreas Fault.
What do you think happens when crustal plates move past each other?
I think that there's probably a lot of rock that's rubbing against each other on those faults.
Maybe bending and breaking and that kind of thing. All right, so let's demonstrate the movement of the crustal plates along the fault. Students will stand and face each other, and holding down their right hand, they will push palms down. They will slide their hands past each other.
But not very hard, right?
No, not very hard. Okay? Students are directed then to press their hands together more tightly while trying to slide them past each other.
Oh, yeah, that feels a lot rougher.
Yeah. Now, what we are going to do is slide our hands past each other with a lot of force.
Okay, so I'll push 2.
Oh. Okay, try it again.
Oh, our hands went over top of each other.
Something had to give. Rocks along a fault do not slide smoothly and steadily past each other. Rocks are tightly packed together and sometimes become stuck. As the pressure builds, the rocks may suddenly become unstuck and slip past each other with an unexpected and violent jolt. What would this model represent, Kathy?
An earthquake.
Okay. How were your hands like the rocks along a fault?
Well, it seemed like as we added more pressure, they were rougher against each other. They slid past each other and even overlapped each other.
Okay, the greater the strength, the more force. Next, each team of 2 will be given a rubber band. One student is instructed to stretch the rubber band while the other student plucks. You hold the rubber band, Kathy, and I'm going to pluck. What do you observe?
Oh, I see the rubber band going back and forth.
What do you hear?
Well, I hear a sound that sounds kind of like a guitar string.
A vibration is a back and forth movement, such as what you just observed with the rubber band and what you heard. Do you think sounds can travel through solids?
Well, you know, I'm not sure.
Okay. Why don't you, and the students, we asked to put their ear to the desk. In each team of 2, one student will put the ear to the desk, and while the other one taps. Okay?
Oh, yeah.
Did you hear it?
It's
It's
pretty
kind
loud.
of deep. Okay. What I'd like for you to do now is to put your ear near the desk. This is what the students will be doing, and I'm going to tap again.
Oh, that wasn't nearly as loud.
Okay. When you had your ear to the desk, how was the sound traveling?
Through the desk,
Okay, through a solid.
through a solid.
When I tapped the second time and you heard a difference in the volume of the sound, how was the sound traveling then?
Through air.
Okay. Now students will explore a third model to help them further understand what happens when 2 plates slide past each other. You're going to be giving the students 5 dominoes, and we're going to line those dominoes up. Kathy, you can help me do this. In a straight line. And then you're going to ask the students to knock on the desk to find out, to discover what happens to the dominoes. What did you observe?
Oh, they all toppled over on top of each other.
Okay, why does this happen?
Well, I think that vibration that you did by hitting the desk knocked them over.
Okay, when sections of the Earth's crust move along fault lines, the rocks stretch and snap, just like the rubber band. This stretching and snapping of the rock sets up vibrations that travel through the solid Earth. The vibrations cause the ground to shake in what is known as an earthquake. What might happen during an earthquake when the earth is shaking and the ground is vibrating?
Well, if these were buildings, I'm thinking the buildings would maybe topple over like the dominoes did.
Exactly. What could have been done to keep the dominoes from falling over?
Well, we could have maybe taped it down so that it wouldn't fall over.
Okay.
Or maybe we could have turned it on its side so it wouldn't have been as tall, maybe not as easily toppled over. Or maybe we could have put a medium under there like sand and stuck it down in there, submerged it under a little bit so it would have some strength to not fall over.
Okay, good idea. In the United States today, buildings in earthquake-prone areas must meet strict building codes that are designed to protect the people who live and work in the structures. For example, new high-rise structures in Los Angeles, California are anchored to flexible moorings made of steel and rubber plates. These plates absorb much of the vibrations produced by earthquakes and minimize structural damage to the buildings themselves. Some students may be willing to share their experiences in earthquakes. For cleanup, students may keep their puzzle pieces, return the dominoes and the rubber bands to the kit. Guide the students through reading pages 9, 10, and 14 in the Delta Science Reader.